This video is about determining the theoretical probability of an event. It's lesson 14, and in your books it's on pages 74 through 79. Here's some definitions that have to do with theoretical probability, and you're definitely going to want to write these down because we're going to be using them a lot. First, we have sample space. The sample space is the set of all the possible outcomes of an event. For example, if you're tossing a coin, all the possible outcomes are heads and tails. So your sample space is heads and tails. If you're rolling a die, then all the possible outcomes are 1, 2, 3, 4, 5, 6. So that would be your sample space. A simple event is an event having only one outcome. For example, rolling a 5 on a number cube, or getting heads when you flip a coin. That's a simple event. And finally, theoretical probability. That's the ratio of favorable outcomes to all possible outcomes. Now, that word ratio indicates that we're going to need to divide. So we take the number of favorable outcomes divided by the number of possible outcomes. For example, the probability of tossing a coin and landing on heads is 1 over 2. 1 being how many favorable outcomes there are landing on heads, and then 2 being the total number of possible outcomes. So heads and tails, 2 possible outcomes. The probability 1/2 can also be written as 0.5, or it can be written as 50%. Here we're going to identify some sample spaces. A number cube labeled 1 through 6 is rolled, and we want to list the favorable outcomes for each event. So number 1, rolling a number that is less than or equal to 3. All our possible outcomes that are less than or equal to 3 is obviously 3, and then all the numbers that are less than 3, so 2 and also 1. Those are all the numbers on a number cube that are less than or equal to 3. This is an example, by the way, and this needs to be in your notes. Number 2, rolling an odd number. The possible outcomes here are all the odd numbers that are on a number cube. So on a number cube, we have 1, we also have 3, and we also have 5. And then number 3, rolling a number greater than 4. So we need to list all the numbers on a die that are greater than 4. So that gives us just 5 and 6. To find the probability of an event, as I said before, and we usually write that P and then in parentheses event, the probability of an event. It's the number of favorable outcomes, the number of outcomes that we're looking for, divided by the total number of possible outcomes. The complement of an event is the set of all outcomes of an experiment that are not in the given event. Now, what does that mean? When you're flipping a coin, you can get heads or tails. If the desired event is to land on heads, heads is the favorable outcome. Tails would be the complement of that event because it's all the outcomes of the experiment that are not in the favorable category. Another example would be if your desired outcome is to roll a 3 on a die, the complement of that would be rolling a 1, 2, 4, 5, or 6. The sum of an event and its complements always equals 1. So like before when I said that if your favorable event is rolling a 3 on a number cube, there's 1 3 out of 6 numbers on a number cube. And then there are 5 other numbers that are not 3, 5 out of 6. So the probability of getting the 3 is 1 out of 6. The probability of not getting the 3 is 5 out of 6. And whenever you add the probability of the event plus the probability of the complements, you will always get 1. 1 plus 5 is 6. 6 over 6 is 1. Now let's do some calculations of theoretical probability. Here we have a bag, and there are 4 green, 3 blue, and 3 red marbles in the bag. And we want to give each answer in decimal form and a percent form. This also is an example, and it definitely needs to be in your notes. Number 1, what is the probability of randomly choosing a red marble? To find theoretical probability, we want the number of favorable outcomes, in this case, choosing a red marble. and we're going to divide that by the total number of possible outcomes. So if we look here, we have 3 red marbles in the bag. So our favorable outcome are 3. There are 3 red marbles that we could draw. To find the probability, we're going to divide that by the total number of outcomes, or the total number of marbles in the bag. So there are 4 green plus 3 blue, that's 7, plus 3 red, so that gives us 10. The probability of randomly choosing a red marble is 3 red marbles out of 10 total marbles. We want to give these answers in decimals and in percent. So if we were to write 3 over 10 in a decimal, it's 3 divided by 10, which is 0.3. If we want to give 0.3 as a percent, we move the decimal point 2 places to the left, to the right, and it's 30%. The next question is, what is the probability of randomly choosing a marble that is not green? Okay, so this is our favorable outcome, some marble that is not green. To find the probability of this, we need to count how many marbles are not green. Now, there are 4 green ones, but we want to know how many there are that are not green. So we have 3 blue, that's not green, and 3 red, that's not green either. There are 6 total blue and red marbles. Out of how many possible marbles are there for you to draw from? 10. So the probability of drawing a marble that is not green is 6 out of 10. Now we need to write that as a decimal, so 6 divided by 10 is 0.6. And if we want to change that to a percent, we move this decimal point 2 places to the right and get 60%. Let's calculate some more theoretical probability. In the bucket, there are 10 balls numbered as follows: 1, 1, 2, 3, 4, 4, 4, 5, 6, and 6. A single ball is randomly chosen from the bucket. What is the probability of drawing a ball with a number greater than 4? And is there a greater chance of drawing a number greater than 4 or a 1? Okay, so we'll start with the first question. What is the probability of drawing a ball with a number greater than 4? Well, what possible numbers can we draw greater than 4? We've got 5, there's only one of those, and then we've got 6, and there are 2 6s that the balls are numbered. Okay, so how many favorable outcomes do we have? We have 1, 2, 3 balls in the bucket that are numbered greater than 4. So it's 3 out of how many total balls are in the bucket? 10. So the probability of drawing a ball with a number greater than 4 is 3 out of 10. That's the first question. The next question says, is there a greater chance of drawing a number greater than 4 or a 1? So we know the probability of drawing a number greater than 4 is 3 out of 10. Now we need to find the probability of drawing a 1 and compare it. So how many 1s are in the bucket? 1. So the probability of drawing a 1 is 2 out of the total number of balls in the bucket, which is 10. Now it's obvious that 3 out of 10 is definitely bigger than 2 out of 10. So for this question, there's a greater chance of drawing a number greater than 4. 3 out of 10 as opposed to 2 out of 10. Again, this is an example, and it needs to be in your notes. This is the last example, and it needs to be in your notes as well. At a carnival game, you drop a ball into the top of the device shown below. As the ball falls, it either goes left or right as it hits each peg. In total, the ball can follow 16 different paths. That number tells us how many possible outcomes we have. The ball eventually lands in one of the bins at the bottom, and you win that amount of money. One path to $0 is shown. What is the probability of winning $2? In order to find the probability of winning $2, we need to know how many total paths are there to $2, and we need to divide it by the total number of paths it can follow, which we know is 16. Now, if we look at this diagram here, you can see that there are two possible slots where you can win $2, and there are these ones on either end. Now, the only way that you're going to be able to win $2 is if the ball comes down and goes directly to the left, or if the ball comes down and goes directly to the right. If you go any other way, like if you get caught between these two, it's either going to go in the $0 or the $1. And if you get caught between these two, it's either going to go to 1 or 0. So the only way that you can win $2 is to go all the way to the left or all the way to the right. So you have two possible routes to the $2 spaces. Out of how many total paths could the ball follow? It can follow 16 different paths. So our probability is 2 out of 16. But we can't leave it as 2 out of 16. We definitely need to simplify that. 2 divided by 16 is the same thing as 1/8. So our probability is 1/8. Now, if we were to write that as a decimal, we would divide 1 by 8, and we would get 0.125. So we can say our probability is 0.125. Or if we wanted to turn it into a percentage, we could say it's 12.5%.